October 30th, here's the daily sheets. So, the do now, determine the length of each side. So this is a review. So here are our coordinates. And our coordinates are always written x comma y in parentheses. And it's done that way everywhere. So, well, let's look at our first coordinate. It's 0, comma 4. So we go along the x-axis to 0, which is right here, and then we come up to number 4. Here's our second point, 4, comma 4. So we come across to the 4 for the x, we come up to or across from the 4 on the y. So there's corner 1, there's corner 2. Alright, here's the third corner. Or we could say A and B. So let's look at corner C. 4, and they come up to the 7. So this would give us a triangle. Neatness counts. You can use anything for a straight edge, as long as you have a straight edge. So we see we have 3 units long. That's for side A, which would be we call that our height of a triangle. B, we call this our base. We notice that it's 4 units long, and we want to figure out how long side C is. That's our hypotenuse. So, it's pretty easy. We just use the Pythagorean theorem. Now we're saying side A is 3 units long. So wherever there's an A, we put a 3. And since we're squaring the A, we also square the 3. And we're going to add that to the length of side B, which is 4. We're squaring B, so we would square the 4. And we do not know the length of side C, so we use an x. That x is some number. It's a particular number. We just don't know which number it is, but we're going to use the x to show that we're looking for a number right there. Alright, since the c is squared, the x is also squared. So we square the 3, that gives us 9. We square the 4, that gives us 16. But we still don't know what that x is, so we have to leave it alone, but bring it down. So we add the 9 and the 16, that gives us 25. Alright, now we can find out what x means. See, the thing is, we don't want to know what x squared is. We want to know what x is. So, when we try to undo a square, the inverse of a square, we use square root. And because we have an equal sign, we have to keep things equal. So whatever we do to one side, we can do to the other. We can do anything we want, as long as we do the same thing to both sides. Well, what we want to do is undo this square, so we're going to square root. This will give us x, and that will equal 5. So, there we have it. So the length of A to B, there's A to B, that's our base, that is 4. The length of B to C, there's B, there's corner C, that is 3. And the length of A to C, that is 5. Alright, another review. Draw the following equation on a graph. So we're going to call this number 1, number 2, number 3, number 4. So, in quadrant 1, we have y equals negative 3x plus 4. So let's go with a known point. This plus 4, that's our y-intercept. So we can put a dot on the positive 4 and negative 3. Well, this is right there. That's our slope. And that equals rise over run. So a positive 3, a whole number 3, whether it's positive or negative, can be expressed in a fraction as 3 over 1. Since it's a negative, we'll make the 3 the negative. So what this means is our rise of negative 3. So we're going to come down 3, and we're going to run over 1. And we put a dot. Now we can make a line with just 2 points, but I like a nice straight line. It's easier to do that with 3 points. So 1, 2, 3 over 1. You take your straight edge. There we have number 1. So here's quadrant 2. Alright, so let's look over here. So y equals negative 1/2 x minus 4. Okay, so this right here, that's a negative 4. So the sign always goes with the number. So we have a negative 4. Now, if we look at here, our m, it's already in a fraction, which is good because of rise over run. So we have a negative 1/2. So rise is negative 1 and run is 2. 1, 2, 1, 2. Okay, we can follow that pattern. But if we have 3, we're good. I happen to have 4. There we go. This is line 2. Let's take a look at line 3. Here we have negative 6. That's going to be our y-intercept. See, the thing about the y-intercept, that's where the line crosses the y-axis. That's why it's really good to have this y-intercept, because we have a starting point. Alright, positive 3 over positive 2. That means our rise is going to be a positive 3, and our run is going to be a positive 2. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. Using 3 points helps us to make sure that we're following the correct rise over run. Pardon me. This is line 3. Line 4. Positive 5 for our y-intercept. And then our slope is positive 2 over 1. So 1, 2, 1. 1, 2, 1. Okay. And this is number 4. And we're done with the second do now. Alright, so those two are a review. Both of these were a review. Now let's get into something new. We're going to talk about interest. Interest is important because interest shows growth over time at a certain rate. That's not all that much different than our slope. Our slope represents a rate, and our y-intercept represents a starting point. Well, when we're talking about interest, our principal, that's the money we start with. That's our starting point. And our rate, that is the interest. Now, that doesn't translate into what we just did exactly, but conceptually, your interest is a rate. You have an interest rate. Now you can determine an output of the actual amount of that interest in terms of what it produces. But really, interest is oftentimes expressed as a rate, like APR, annual percentage rate, that sort of thing. You'll see that. But let's not concern ourselves so much with that. There's a couple different kinds of interest that we need to be aware of. There's compound interest and there's simple interest. And we'll get into compound interest later. But right now, we're going to deal with simple interest. So, simple interest is interest paid on the principal only and not on any accumulated interest. So, this may happen in 1 year, like you'll earn a certain percentage rate during 1 year, or it may happen over multiple years, but the interest is not calculated on any accumulated interest from previous years. So, for example, simple interest over a 5-year period of time. Let's say the interest was 5% and the principal was $100. So we take the $100 and multiply by 5%, and at the end of the year, that means that it would cost whoever borrowed that $100 $5 to do that. Well, next year, we would pay $5 in interest again. And the next year, $5 in interest again. And the next year, $5. See, with compound interest, the first year, that loan would be worth $105. And so in the second year, the end of the second year, you would charge the 5% against the 105. In the third year, against whatever the total value was from the second year. And it goes on and on and on and on. Well, with simple interest, we don't do any of that. It's just, if it's 5% and you borrowed $100, you're going to pay $5 each year. Your payment will stay the same. Interest will only be charged against the principal. Alright, so let's take a look at this. So, a student puts $1,200 in savings, paying simple, and the savings account pays a simple interest of 4.5% per year. So, if the $1,200 stayed in that savings account, at the end of the first year, the student would get 4.5% of the $1,200 added to their $1,200. And then the next year, if they didn't take any of the $1,200 out, another 4.5% of the $1,200 will get added to the $1,200. However much interest was earned at the end of that first year is ignored when making the interest calculation. So let's figure out the total amount of the student's savings after 5 years. So there's really two parts to it. This is part A, and this is part B. So let's look at part A. The principal, that's just $1,200. Okay, and we're going to add that to part B. Well, the interest. So we have the principal times the rate times the time. So the principal, we say, is $1,200. And we're going to multiply that times the rate. And that's per year. But it's not 1 year, is it? No. It's 5 years. Alright. So let's do this. Calculate this up. So we have 1,200 times 0.045, because that's the decimal equivalent of 4.5%, times 5 years. And that's going to produce $270 of interest. So we have 270. Well, that's the interest. But we know that the amount that we want equals the principal plus the interest. Principal plus the interest. Principal is A, interest is B. We calculate the interest, principal times rate times time, substitute those numbers, and so our answer is $1,470. Now my recommendation is set your problem up like this. It's a lot easier to keep track of what's going on. Alright, let's take a look at the we do. So a student puts $1,000 in a savings account paying simple interest of 3.5% per year. Find the total amount of student savings after 6 years. So let's circle our important numbers. There's $1,000 in principal. Here's our rate. Here's our time. So, there are two parts. A plus B. We know that $1,000, that is our principal, and we know that principal times rate times time, that gives us our interest. So the principal is $1,000 times the rate times the time. So what we'll have is our principal plus $210, and that's going to give us our amount of $1,210. Oh, looks like my paper slipped. There we go. So, principal plus interest gives us $1,210. So let's take a look at another we do. Here we go. So remember, principal plus interest, that's going to give us the amount we're looking for. So we have $500 of principal, two parts, A plus B. So simple interest rate, that's key, 4.5% per year. Oops, 500. And 2 years. So 500 times 0.045 times 2, that gives us $45 of interest. So our amount equals 545. So our question though is, which of the following is the closest to the interest she earned in 2 years? So we're not looking for the whole amount now. We're just looking for the interest. There we have it. So the next question is a you do. So I'm going to let you do that one. And I'm going to stop the video right here. Alright.